Okay, so we're going to be factoring trinomials when a is not equal to 1. Before we do that, let's just recap how to factor when a is in fact 1. So if I gave you a trinomial such as x squared plus 8x plus 16. First of all, we talked about how quadratics are in this form, ax squared plus bx plus c. So before we begin, can someone just tell me what a is in this case? 1. It's always the coefficient of the x squared, right? And if there is no number written there, we always assume it's a 1. B in this case would be 8, and c would be 16. Okay? So when I am talking about factoring, I'm going to be referring to a, b, and c quite a bit. That's where I'm getting those numbers from. Okay? It's just the coefficient. A is always the coefficient of x squared. B is the coefficient of x, and c is the constant on the end. All right? So to factor these, remember, it's just like when you did factor trees. When I asked you to do a factor tree for 10, you split it into 5 times 2. I'm doing the same thing. I'm splitting this into 2 binomials, such that when I FOIL those binomials back together, I get to this original. So the pattern that we follow is we find factors of c, which in this case is 16. I want factors of 16. What are factors again? What's factor mean?
Like what you multiply to get to.
Right. Factors are numbers that divide evenly into 16. So there's certain pairs. There's 1 and 16. There's 2 and 8. There's 4 and 4. And that's it, right? So here's all of my factor pairs for 16. I'm looking for specifically the factor pairs that add up to be 8. So which of these add up to be 8? 4 and 4. So once I have my factor pair, I get to split this up. So I'm just going to rewrite my quadratic right there. Once I have the factor pair, it splits into 2 binomials, and it's x plus 4 and x plus 4. Okay? It just so happened that these happen to be the same. They won't always be the same, and it doesn't matter what order you put them in. You just put one in each spot. There's another way to write this, by the way. If both binomials are the same, how could you write this? If this were multiple choice, for example, and you were looking at the choices, how else might they write this answer? Jack?
2x plus 8.
No, it's not going to be that. Sierra? Yeah, that's the same thing as x plus 4 squared. So if you happen to have the exact same binomial twice, you can always write it as just one of them squared. Okay, so before we move on to when a is not 1, let's just do one more that has maybe subtraction in it. So let's say we had x squared minus 6x minus 27. So, Audrey, what is c in this case? Negative 27, correct. So this time you want numbers that multiply to be negative 27 that add up to be a negative 6. So just start listing. Give me some numbers that multiply together to get you 27.
1 and 27.
1 and 27. Now, since it's a negative 27, one of these has to be negative. So either it's a negative 1 and a positive 27 or the other way around. Do either of these add to be a negative 6?
No.
No, so that's not the right pair. So think about another pair of numbers that gets you to 27. 9 and 3. One of these has to be negative. If I want to add to be a negative 6, which one has to be negative? The negative 9.
A bigger number.
Right. In this case, the bigger number, since I wanted it to add to be a negative 6, the bigger number is going to be negative. So now I found my factor pair, a negative 9 and a positive 3. So when I go to write the 2 binomials, it's just going to be an x minus 9 and an x plus 3. That's the same thing as if you had x plus 3 first and x minus 9 second. That doesn't matter. It just matters that you have the negative with the 9 and the positive with the 3. So that's the gist of factoring when a is 1. Now, occasionally, you'll see something like this. Let's do this here. Say I had 2x squared minus 18x plus 40. This is kind of what we had done yesterday. You're like, well, a is not 1 here, Mrs. Sabia. You have not yet taught us how to do this. However, in this case, if you look, isn't there a common factor? Yeah, you can take what out of all of them? 2. So I'm going to factor a 2 out, and then what would be left behind?
X squared minus 9 plus 20.
You got it. So now you do have a trinomial where a is 1 inside the parentheses. So now you just factor like I just showed you. So I would want factors of 20 that add up to be negative 9. What has to be true about the factors if they multiply to be a positive number but add to be a negative? They're both negative. So what two negative numbers multiply to be positive 20 but add to be negative 9? Negative 5, negative 4. So we're going to have x minus 5, x minus 4. So that's what we had worked on yesterday. Just make sure that the 2 that you factored out, or whatever you factored out from the beginning, has to be part of your answer. So if you are asked to factor completely, there is your final answer. Okay, now let's talk about when a is not 1. Oy. Okay. It's actually not that bad once you get used to it. So let's pick a nice example. How about, okay, we're going to try this one. 2x squared minus 9x minus 5. So first thing, so we're going to write some step-by-steps over on the side. So 2 factor when a is not 1. A is not equal to 1. First thing you should always do, factor out a common factor if there is one. Factor out a GCF if possible. If you don't do that first step, you're going to make your life so much harder. So I implore you to not forget about step 1. Is there a common factor that I can factor out of my example? No. They don't all have a common factor, and there's no variable for me to take out. So step 1 in this case is done, but at least I've tried. Okay, step 2. We are going to multiply a and c together to get our new number. Multiply a times c. So in our case, what is a?
2.
What's c? So a times c gets me negative 10. So I'm multiplying a times c, and I got negative 10. Can you guys see that? Green's not showing up as well for me. All right. So now what I'm going to do is I'm going to use, yeah?
That wouldn't be, like, how would you rewrite that after you get to the negative 10?
Well, I'm,
Like, how would you rewrite the problem?
I'm getting there.
Oh, okay.
This is just like, remember on this last one, once I wrote on the side to find my factor pairs? Same thing. So I'm just writing this on the side, I'm going to find my factor pairs, and then we'll go from there. Okay. Once you've multiplied a and c together, now it's similar idea. I want to find factors of this number that add up to be b. So instead of it just being factors of c that add up to be b, it's factors of a times c that add up to be b. So now I want to find factors of that number that add to be b. So similar to yesterday, you just have to multiply the numbers first. So let's look at negative 10. What are factors of negative 10 that add to be negative 9? Negative 10 and a positive 1, right? If you weren't sure, just keep listing them until you find them. Negative 10 and a positive 1. So I found my factor pair. I wish I had a little more room. Okay. So once I found my factors, here's the next weird step. Step 4, you're going to rewrite the trinomial, but replace the middle term with the 2 factors you just found. Let me give you a second to jot that down, and then I'll show you what I mean. Okay, Is everybody clear where the negative 10 and the 1 came from? All right, so now I'm going to rewrite this exact trinomial. I'm going to write it down here just so I have a little bit more room. But instead of writing negative 9x, I'm going to split it into negative 10x plus 1x. So, watch. 2x squared, and then the middle term, now I write it as negative 10x plus 1x, or just x, right? Well, I'll put a 1, just so we remember, minus 5. Can you all agree with me that this is the exact same thing as this, right? If you combine negative 10 plus 1, don't you get negative 9x anyway?
Yes.
Okay, so I haven't changed the problem. I just wrote it in a little bit of a different way. And that's setting me up for my next step. All right, so I rewrote it. I replaced that middle term with the 2 that I just found. Does the order matter? No. If you had written plus 1x and then minus 10x, doesn't matter. So we don't care about the order. Once you have this, though, I draw a line down the middle. So I don't know. I think that's easier. So draw a line after the second term. So my second term is a 10x. I'm going to draw my line right after it. I'm careful, though, not to draw it over the plus sign here, because if that were a minus and you drew the line over it, you might think that it's a plus. You get what I'm saying? So just be careful. I write it right after that second term. Now I have 2 sections, a section at the beginning and a section at the end. You're just going to factor each section separately. So if I just look at this front part, 2x squared minus 10x, what factors out of that? 2x, right? 2x, and then what would be left?
Minus 10.
Well, remember what we're thinking. What did you multiply 2x by to get 2x squared? You'd be x, and then what do you multiply 2x by to get negative 10x? Negative 5. Okay, on the other side, what can I factor out of 1x minus 5? Yeah, there's really nothing that I would normally pull out, but I have to take something out, so the only thing I'm going to take out here is a 1. Okay, so I'm going to take out a 1, and then I'd still have x minus 5 left over. Nothing changed, right? Because if you just factor out a 1, you're not changing anything. We'll do another example where that does not happen. Guys, do you notice anything similar about the 2 sides?
Same inside.
Right, and that will always be the case. If you don't have the same thing in the parentheses on each side, that's a nice little thing that math is doing for you by telling you you messed up already. So stop and go back. So this is a nice spot to do a little self-check. Those 2 parentheses have to be the same. Okay, so let's get caught up in our steps here. So step 5, draw a line after second term. 6, factor each side. And I'll just say there's 2 little notes that I need for this step. If there's nothing to factor out, you're going to factor out a 1, just like we did. That doesn't happen that often, but when it does happen, make sure that you don't forget. Oh, geez. Hold on 1 second. Good morning, Miss Savia. Good, how are you? Okay. You need to budget at least 3.5 hours from the ending time. At least. Yeah, because yeah, that sounds reasonable. Yep. Jay will, not me. It's him and his dad have the tickets. I go to ones where they're, because they know the people next to them. So if they don't go, yeah. No problem. Bye. Am I? Yeah. In New York. Whenever that is. I don't know. All right, guys. So there's that line to factor out. Take out a 1. The next important thing. Guys, this one's super important. So big star. This is the self-check. If the parentheses do not match, stop. Something's wrong. Don't forget that, okay? So if your parentheses don't match, just stop right there and go back. There's already a mistake. All right, but for us, ooh, our parentheses match. We don't have a mistake. So watch how this breaks down now. We're still going to have 2 factors, just like when let me go up here real quick. Just like when I factored this trinomial, I got 2 binomials out. I'm going to have the same thing. This is going to turn into 2 binomials. How does that work? Well, whatever is in the parentheses, that's one of them. So one of my 2 factors is x minus 5. The other one, and kids always forget where this other one comes from. It's just what's out in front, 2x and a positive 1. 2x plus 1. That's it. So now you could FOIL those back together, and you will, in fact, get right back to the original, which was way up here. 2x squared minus 9x minus 5. So let's just try it. If I FOIL, so here's our check. First, what's x times 2x? 2x squared. Outers, x times 1 plus 1x. Inners, what's that? Negative 10x. And then last would be minus 5. Put it all together. 2x squared minus 9x minus 5. You've got it. Yeah, sorry.
So we take the outer ones and make it the second parenthesis?
Yeah, it doesn't matter whether it's the first one or the second one. Whatever they share, that parenthesis is one of your factors. And then the 2 bits out in front, you put them together into one. Okay? So now we're going to do some more practice ones. So let's see. Let me find a good one while Courtney finishes up there. How about we do, that's a good one. Did you get it, Courtney? Okay. All right, so let's move to a new sheet. We're going to try this one. 3x squared minus 2x minus 8. So, step 1. Is there anything to factor out of this? No, not this time. Step 2, you're going to multiply a and c together. What does that get me? Negative 24. I want factors of negative 24 that do what? Add to be negative 2. So, I don't know. What do you got? 3 and 8? Does that work?
No, negative 6 and 4.
There it is. Negative 6 and a positive 4. Okay? Once you find your factors, this is what's different. Now you have to go back and you have to rewrite this. Plug these 2 pieces in. So it looks like this. 3x squared. Now instead of writing this, I put these 2 in. Minus 6x plus 4x minus 8. Then I draw the line. You don't have to draw the line. That's not crucial, but I think it's much easier. And now I just factor each side. So look at the front here. What can you factor out? 3x. And what would be left?
X minus 2.
X minus 2. On the other side,
Just the inside is going to be the same, but not the outside.
right, right. Over here, what can I take out? A 4, and what would I be left with?
X minus 2.
X minus 2. So remember, you need to check, do my parentheses match? Yes, they do. Hooray! So that's one of my factors is x minus 2. The other one is 3x plus 4. You've got it. There are a few weird situations that come up. I'm trying to think of... Give me 1 second and I'll make up one that comes out weird. Yeah. It's whatever is out in front. Whatever you factored out of each one, you put them together right there. Do you get where these... Okay, so now I'm just looking at 3x squared minus 6x, and I factor what I can out of just those two. So I can take out a 3, and I can take out an x. And then what's left, right? Do you know where the x minus 2 came from? Okay, so I do the same thing on this side. I can take out a 4, and then I'm left with x minus 2. And then, to write my two factors, whatever they share, that's one of them. And then the second one, I just put what's out in front together. So 3x and a plus 4. Yes. If they're not the same, something's wrong. So don't keep going. Okay. 2x squared plus 3x. Okay, guys, let's try this one. Say you had 2x squared plus 3x, 2x squared plus x minus 3. Let's say that was your quadratic.
So you got to add B1.
I have to, b is 1, correct. So, anything to factor out? No. Right, so now I want to multiply a times c, that gets me a negative 6. And I want factors of negative 6 that do what? Add up to be a positive 1. Negative 2 and positive 3. Okay? So now I'm going to rewrite this. I'm going to write the 3 first just because I want something to happen. So watch this. 2x squared plus 3x minus 2x minus 3. Everybody's okay? So I rewrote the trinomial, but now I replaced the middle term with the two factors I just found. Now, split it down the middle, right after that second term. So from the front, 2x squared plus 3x, what can I take out? Just an x. And what would be left behind? 2x plus 3. Good. On the other side, look what's going on here. This is a positive 2x plus 3. That's negative 2x minus 3. So what do you think I have to factor out? A negative 1. Yes. Take out a negative 1 this time, and what would that leave behind? Careful. 2x plus 3. So sometimes there was nothing for me to take out here, so why didn't I just take out a positive 1? Because I knew I needed it to be a positive 2x plus 3. Yep.
What if you did it the other way? What was like
It won't matter. I'll do it. I'll flip it. You mean have the 2x right here?
Yeah.
Yeah.
I got 2x, x minus 1.
That's okay, because watch what happens now. What are my two factors, guys? 2x plus 3, whatever they share is one of them, and then the other one is x minus 1. So, Tom is asking, what happens if you had done this instead? When you rewrote it, you had the minus 2x first and then the plus 3x. It doesn't matter. You're going to end up, our ending point will be the same. The middle will look a little different. So if you had done this, if I split it down the middle, what could I factor out from this side? 2x. And what would be left? X minus 1. What could I factor from this side? 3, and I'm still left with x minus 1, right? So one of my factors is what they share, x minus 1, and then the other one comes from in front, 2x and a plus 3. So your ending point is the same. Remember, it doesn't matter the order. What does matter is that you have the 2x plus 3 is one term, and the other one's x minus 1. Does this kind of make sense?
Yeah.
By the way, there are several names for factoring in this way. One of them, which your book uses, is factor by grouping. And do you see why it might be called that? You're making two groups, and you factor each group. So factor by grouping is one way. I've also heard this called British method, I think, which, I don't know, so if you're looking online and something says British method, same idea, I guess. I don't know, maybe. There is another, sometimes people just call this the AC method because you're multiplying A and C together. I just want you to be familiar, so if you hear other people saying these things, we're all talking about the same thing. Are there other ways to factor trinomials when A is not 1? There are, but in my opinion, this is probably your easiest way. There's something, when I was learning this, called guess and check, which was super annoying, and you literally just kept guessing and checking and hoping that you found the right combination. It's not that bad when A and C were prime numbers, but when A and C have a lot of factors, then guess and check is a nightmare because you're just playing around with the factors hoping to get ones that add up to be that work out. It's terrible, in my opinion. AC method is nice because there's steps that you follow. You do this, 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 and then you're all set. Okay, so we're going to practice some more, but I think that's it for the video. Is there anything else that, any other questions that you're still not sure about that you want me to clarify, Cam? No. That needs to be in the video?
Yes.
Okay then, go ahead. All right, anything else? We're good? Okay.